All right, everyone, and welcome to today's webinar. The webinar will be around sustainability and decarbonization. And me, the presenter Magnus, together with Ali, we will show you how we can minimize CO2 emissions and the climate impact during road and railway projects. So we think we have split the agenda in 5 parts. We will run through a very fast introduction, looking at the opportunities and goals. We'll dig a little bit into the connected construction, the different Trimble applications. And then we will look on the CO2 calculations inside particular 2 tools in 2 different phases. In the route selection, in the early phase, how we can optimize sustainability and CO2 in like the concept in the early design phase. And Ali will take it off from there and look how we can create a time location plan and also work with CO2 emissions in a later stage of the project. Okay, so most attendees in this webinar is particularly from Europe and Northern Europe. And our national transportation plans in Scandinavia has 3 main goals. It's build more infrastructure for the money that is available, and build this infrastructure with new, modern, efficient technology. And what's more into our webinar today is we need to fulfill the climate goals. And the challenges we are facing today that we need to try to solve in order to reach those goals is they have a long time. Projects take too long time to plan. Most of them are actually run over the budget. We face a lot of conflicts. The project has to be redone. You have to redo a lot of work due to several conflicts. We also need to improve our workflows. I mean, both between people, but also between software and tools. And the CO2 part, 60% comes from our transport sector. So we need to really improve on the CO2 values. So the Trimble connected construction. What we in Trimble try to help with in the industry is to make sure we can have a plan and a red carpet throughout the entire connected construction. So from early design to our concept, planning, scheduling, execution, and also maintenance, that we can make all these parts fit closer together. And in our world, a project could look like we start with the concept, the feasibility. We go through route options, design, cost, visualization, planning, and then we do send the data automatically out to the field. And a few tools that we can use in this ecosystem is internal Trimble tools, like many of you are used to working with, the Quadri, the CDE BIM platform in the middle, and a lot of the tools around. So this can be internal Trimble tools, or we can also connect with like Civil 3D, Bentley, Grasshopper, and tools like that. But since we're going to focus on the CO2 part, we have chosen for this webinar to focus on Quantum, which are used in the feasibility and route option, route selection phase, which is the part where we can change the most, where we have the most abilities to influence. And Ali will cover the time location planning in Tylos. And we can also show you the integration in between them, where Quadri is also a really nice part of the workflow. So I can start off with Quantum, which is maybe one of the most important CO2 softwares we have within Trimble, at least in the early design phase. And with Quantum, we are able to actually calculate and reduce CO2 from the construction phase, and also from the future traffic that will run along our highways. So the fine thing and the great thing about Quantum is it's an algorithm that can evaluate all the different route options from A to B. And from A to B, there's so many factors that will affect a project. And we need to try to avoid protected areas, like where animals are living, where we have quick clay, culture, heritage. These very, very important areas need to be avoided, not at all costs, but it's really important to consider them when you're selecting the best route. And then during the planning, it's great to evaluate millions of route options to ensure that we have maybe also the low cost options, but also options that do not affect the CO2 that much, both in the construction phase and the traffic phase. And along with CO2, it's also important to evaluate and consider the costs, because if we consider all the environmental items, the infrastructure project can also be too expensive. So it's nice to evaluate CO2 and cost in relation to each other. We'll also dive a little bit into how we can calculate and indicate also noise, because noise is also a very interesting topic and parameter when it comes to sustainability. But the great thing is we have this tool, we have equipment and technology that can help us. Quantum particularly will find and give you all the different route options from A to B. And up in the right corner, we can see all the different alignments, and we can sort them based on how much CO2 they will produce from the construction phase and the CO2 phase. And down left, we can also calculate CO2 from the traffic, meaning we put in the different traffic compositions, like how many percentage of the cars are going on petrol, on diesel, how many heavy trucks do we have, and of course, more and more people are using emission-free cars. We put in the average speed limit, the daily traffic flow, and Quantum will calculate CO2 from traffic also based on the geometry and the grade. So I will open Quantum very, very soon, and we can run a fast demonstration on the topic. And after that, Ali will take over, and I will send my optimal alignment from Quantum to Ali. I will use Tylos, time, location, schedule, where he will plan and show you how CO2 emissions can be showcasted in a little bit later phase and also during the construction phase. All right, I have selected a random project. If I remember correctly, it's from Norway. And we are going to build, or we're going to plan a road from this point to this point. And we see on the map that I have imported a lot of GIS data. For example, the red areas are an airport to be avoided. We have some cultural heritage. We have some very important animal areas. So these red zones need to be avoided at any cost. Then we have other areas in green where we have like the farmland. So we can maybe put in additional costs to cross these green areas. And yellow areas are more where people are living, that have an additional cost to go through these areas. So with Quantum, we can import or draw different features and different areas and give them different attributes to say avoid an additional cost, please don't go through here, force it to go through a waypoint. So there's several possibilities with the GIS data to be handled inside the software. And here we can also consider the landscape, how and structures like bridge and tunnels. Say, oh, this blue river here need to be crossed with this bridge, etc. And we can also add different costs and different CO2 values for everything that will be built. For example, for the different materials in the road, let's say the pavement or the subgrade, we can add different costs and different CO2. For structures, we can add different types of bridges, different types of tunnels, give them different costs and different CO2. And we can apply the different rules in different areas of the project. Say, here we have a river. We need to cross that river with a bridge, 5 meters above at the minimum, and we have to use a concrete bridge or a wood bridge or something like that. We also have areas, like say, we have quick clay or we have some really bad ground, and we have a cost and a CO2 parameter for those areas. And also we have also the geometry is quite important, that it follows the horizontal and the vertical and the grade. And we also have a cross section. What I will suggest in any project in the world, if you have an alignment, like I have on the screen here, if you have worked for a week, for a month, for a year, and had some ideas or even have the design, bring your alignment into Quantum. And I'll tell you why. First, you can import different alignments in different file formats, LandXML or DWG shapefiles. Really easy to import your alignments. If you are working with Civil 3D, Bentley, NovaPoint, or Quadri, it's even easier because Quantum is directly integrated with Quadri. So alignments and GIS data and terrain models flow back and forth. So whatever you have in Quadri, whatever alignment you're working with, you can send it to Quantum, import alignments, bring in any file format, or you can just bring information from Quadri. This allows you to not work with files, not export and import files. You can just send data between Quadri and Quantum through the API. And Quantum now has the same user interface, the same icons, the same expression as Quadri and NovaPoint. So this is not a new routine. This is just another way of finding the optimal alignments, evaluate all the options. And we can now calculate CO2 emissions for the route that you already have. Or we can use Quantum to calculate millions of different route options. And we can go into our comparison list, and we can see all those 20 alignments on the screen in different colors. And we see also the colors in this list, meaning the dark blue are the shortest, the cheapest, and also the alignments with the lowest CO2 emissions. So the software are telling the user that the dark blue alignments, the dark blue corridors are, for example, twice as cheap as the red ones, or has a lot lower CO2 emissions than the green ones, for example. And what we have seen in very many projects is that if you do alignments manually with NovaPoint, Civil 3D, or Open Road, many alignments tends to be low in the list, meaning that Quantum are able to use the mathematical algorithm to find even more cheaper and better alignments for the environment. At least it doesn't cost you much to test with Quantum, because these analyses are done within hours and days. So it wouldn't take much effort to take a project from Quadri or start from scratch and come up with these results. And the great thing inside Quantum is that we have like templates that contains costs and CO2 values. So we don't need to figure out all these values once more. They're already in the template in the software. But of course, any of you with main domain knowledge can go in and adjust the cost and CO2 values. But we have a template that you can start off with, but you are more than welcome to modify or edit any value or any GIS data or any geometric settings as you'd like to fit your project. And even if you're working in a later phase with a road project or a rail project, there is possibilities for huge savings. You can just run this like vertical adjustment. Even if you have a fixed alignment, you cannot improve it anymore. I would say run a vertical optimization, because it can save you. We have seen 5 to 10% savings in CO2 emissions just by improving the geometry, so the cars run more smoother and that alignment fits better to the ground, to the earth, so you have less groundwork. It's also great here within Quantum to work with the quantities. I mean, the cut and fill and the mass movement and the mass haul can also be done inside Quantum. All right, soon off to you, Ali. But first of all, when we have selected 1 or 2 or 3 options, we can open the summary. So for each and every alignment calculated or imported to Quantum, we'll get a summary with the different items, meaning like the cut, the fill, all the materials used to build the rail or the road, culverts, bridges, tunnels, how much areas are we going through. This is quite important. So we can click on it and see, we're not going through any airport, they're not going through any critical areas, but we are taking some building areas, and it will cost this much, and it will give us this much CO2. So with the detailed summary, we can review all items. We can see the quantity of the items. We can see how much it will cost, and we can also see the CO2 related to each and every item that will be built. And in the end, we can also right-click on the alignment, and we can do this CO2 report. Like I showed you in the presentation earlier, we can add different car types, speed limit, traffic flow, yearly growth in traffic, and we can calculate how much CO2 it will cost you yearly, or the next 50 years, or the next 100 years, based on also the growth. So Quantum will basically calculate the length, the cost, CO2 emissions to build the construction, and also the CO2 from the future traffic. And you can also do a noise indication based on the traffic, based on the grade. You can calculate, not calculate, I will more say like you can indicate where it will be a lot of noise pollution in the red areas, and where it will be like medium noise in these yellow areas. This is a very fast way of evaluate, compare, and optimize corridor and alignments for road and railway projects, either you're in a very early concept stage or if you're working with a later design. Now I would like to, for example, send the center line or the entire alignment or the entire project back to Quadri, so that you have the cut and fill and the quantities and the center line, and you can continue with your detailed design in any design application. But in this presentation, I will hand off to Tylos. So now I'll send alignment, cut and fill, where I have bridges and tunnels, and all this information to Tylos with 10-meter or 100-meter interval. I'll send it off to Tylos so Ali can show you what you can do with time, location, schedule, and how you can review CO2 in a later stage, also during construction. So I'll change to you, Ali.
Thanks, Magnus. So I just want to make sure that you can see my screen.
Perfectly fine.
Perfect. So yeah, hello guys. I'm gonna start with talking about Tylos in general. So Tylos is our time and scheduling tool. It has been used by our customer, whether they are project owner or project manager or consultant. Also, our customer, they are a general contractor or subcontractor. They're all using Tylos in their linear project. So the idea is, when you have a linear project, so your project is going several kilometers, it's not enough to know when your tasks are being done. It's also important to know where these tasks are being done. So you will need to have a second dimension, and this is where Tylos will show you that your tasks, so for example, are being planned in like this tasks, topsoil stripping. We can see with Tylos that these tasks is planned between May and June, but we can also see that this tasks is being planned between kilometer 2,400 and between kilometer 2,400 and 0. And we can also see which the activity direction, so our work direction. So like I said, it's really, really helpful to not only know when our task is planned, it's also important with this kind of project to see where these tasks are being planned. So we can make sure that we don't have any collision, or if we have a parallelity in our tasks, we can have like a better overview of our activities. But Tylos can not only do this time and location scheduling, we can also do resource management and our costs management using Tylos. So as you can see on the right side of our plan, we have these diagrams where we can evaluate our resources that we are using in our project. We can evaluate our costs, so how much we gonna have to pay monthly, and we can also do or plan our revenue using Tylos throughout our project. So there's a different functionality we can use Untitled, and as I say, we can use it in early phase of our project, but also we can use it as a controlling tool to see what has been done. Has it done according to our plan? Which changes has come in our plan, in our project, and this kind of information we can also have it updated in our project plan. So this was like an overview of our tiles, like the main functionality and the thing we can plan with tiles. There is, as Magnus has shown, a different API to our different solution, but also to external solutions. So in Tilos, you can always export and import your data or your activity to other scheduling software. So you can easily export your tasks to MS Project or Primavera or Asta Power Project or even Excel. So it doesn't matter which another scheduling tool is being used in the project, because we know like different stakeholder like often are using different tools. So it's easy to exchange data between these other tools. But also we have different APIs to our Trimble solution, like Quadri and Trimble Connect, and also to our Quantum, as Magnus showed. So if I received file from Quantum, I can easily put in this data that I received in Tilos. So this is some project, or this is a road that Magnus has shown and has chosen to work with. He just sent it to Tilos using this API. And as you can see, we can here see our road alignment, and then we can also see our, for example, our cut and fill quantities, and we can see the area where, for example, our tunnels and bridges are being planned. So I took this information, as we can see here, and then I started to plan our activities. These are the activities, the fill and cut activities, as you can see here. And the quantities in these activities are calculated based on the quantity that has been imported from Quantum. So this would be the step where you would start to schedule your tasks. And as you can see, we are planning these tasks based on time. So we can define when our tasks are being made. And also, as you can see, it's location based. And then, like, this is our cut and fill tasks. And here you can see our tunnel activities. You can see here our bridge activities. And of course, you can always connect the activities with each other. And you can, at the end, have your plan scheduled. And as I said, depends on the project phase. You can always update this plan and exchange this information with the different project stakeholder. with using different software. So, for example, if you are using Quadri in your project, you can send this scheduled tasks to your Quadri, so you can have like an overview when the different tasks are being done. And we are talking today about CO2 sustainability. So you also have the possibility to, like, in a later phase in the project where you where you have more information about the machines, the roads, about your resources. So you gather this information throughout your project, and then you can calculate more accurately your CO2 values, and these values you can put in your different tasks, and then you can, as you can see here on the right side, you can make a good diagram where you can show the different CO2 values that are coming from different type of activities. So you have like CO2 coming from your cut activities, from your fill activities. You have like your CO2 values coming from your bridge work or from your tunnel work. So all of these different tasks types and different activities has like different CO2 values depending on the resources that you are using, depending on the different duration, different different roads that you are using to make these activities. So all of this information are easily put in these activities, and as you can see, you can easily evaluate this these values. So it's a really good scheduling tool. It's been used since like 10-20 years from our customers, and like this subject sustainability, as it's grown, it's also been integrated in this solution in Tylos and in our different Trimble solution. So that was like an overview how you can use it, how you can evaluate this kind of values. And yeah, you are welcome to ask your question at the end of this presentation. But for now, I will get back to you, Magnus.
Thank you so much, Ali. I hope that we managed to give you a short overview of how the connected constructions fit together, and that we show two of the connectors to Quadri that can bring information from your Quadri model out to Quantum and out to Tylos, and how you can schedule, plan, show, optimize CO2 in a very early design phase with Quantum, and how you can schedule it with Tylos. An important thing is how they are connected together, so the data and people are working on the same data at the same time in the same project. That's really, really useful. I hope you got some value out of this webinar. Ali and myself will hang out here a few minutes more. If you want to write any questions in the chat or ask them, you are free to do both things. Otherwise, we have recorded the webinar, so it will be sent to your email addresses during the day, so you can review it later or share it with your teammates. But from Ali and myself, thank you for your time. Thank you for joining. Have a really good day.
Thanks a lot, guys. Thank you, Magnus. And yeah, as he said, feel free to ask your question if you have any.
Okay, looks like we will end the webinar. You're free to contact us on email if you have further questions, but for now, thanks a lot.
Thank you, guys. Bye-bye.